Now we're going to take a look at the next section, 6.3, and look at some other formulas for dealing with trig angles. Specifically, we're going to look at double angle, half angle, and then power reducing formulas. So for today, we will start out looking at some of these double angle formulas. And double angle, as you would imagine, we're looking at the sine of 2 times theta, 2 times an angle, the cos of 2 times some angle, and the tan of 2 times some angle. And for the sine of 2 times an angle, it's 2 times the sine and cosine of that angle. For a cosine of 2 times an angle or double an angle, it's kind of interesting because we don't have just one. We have 3 potential formulas to use here. We have this first one, which is cosine squared minus sine squared. And then we have these alternative forms of the same formula, where the cos of double an angle would be 2 times the cosine squared minus 1. And cosine of 2 times some angle would be 1 minus 2 times the sine squared. So these angles here, we can generate these ourselves. We're not going to, but we can get these versions of the same formula just by using the Pythagorean identity, which we know is sine squared plus cosine squared is equal to 1. And then going back here to our list, the tan of double an angle is 2 times the tan of an angle over 1 minus tan squared of the angle. So these are the formulas we're going to use. And taking a look at this first example here, we're going to, I didn't write it, but we're given the sine of an angle, and we're going to look and find the sine, cosine, and tan, all 3 of double that angle. So we're told that the sine of theta is 4 over 5, and that this angle theta lies in quadrant 2. So if we look at our formulas that we have to use here, we can see we're going to need the sine, which we have, but we're also going to need the cosine and the tan of this angle. So let's get started looking at that. So we know here, let me write this as a reminder, sine is y over the hypotenuse, or y over r. So we know our y and we know our r. So I'm going to come over here and make a little xy axis. So here is x, here is y, and we're going into Q2. So we're over here. So this is going to be our theta. And then here I'll make our triangle. So when we look at this, we know that y, this is our y value, this is 4, and then our r is 5. So we have one leg of our triangle, the opposite, we have our r, and now we're going to need to find this x value in order to find cosine and then tan. So in order to do that, use the Pythagorean theorem, and we have x squared, which is our x value, plus 4 squared is equal to 5 squared. X squared plus 16 is equal to 25, and then x squared is equal to 9. 16 minus 25 is 9, and then taking the square root of both sides, we have the square root of 9 would be 3. In our case, I'm going to say it's negative 3 because we can see here from this picture, x would be negative. But if you didn't make a picture like this, because we are in Q2, in quadrant 2, x is negative. So by definition, in Q2, our x is going to be negative. So now we can use this information. We know that cosine of this angle theta is going to be x over r. And since x is negative 3 and r is 5, our cosine is going to be negative 3/5. Looking at tan of this angle theta, tan is y over x. In this case, our y is 4 and our x is negative 3. So there is our tan. So now we have all three trig functions, and let's go to our formulas. So looking at the sine of 2 times theta, so the sine of 2 theta using our formula is 2 sine theta cos theta. So there's our formula. Now we'll put our values in. We have the sine of theta is 4/5, so we have 4/5, and the cosine of theta is -3/5. So when we do our multiplication here, 2 times 4 is 8, 8 times -3, we have -24 over 25. So there is our sine function. The sine of 2 theta. A little different. We're used to fractions looking way different than this, but it is a legitimate answer. Now let's take a look at cosine of 2 theta. And for this one, I'm going to use the first formula just because I feel like it. You could use whatever one you wanted to. So cos of 2 times theta is cos squared theta minus sine squared theta. Again, you could use whatever. I'm using this one. So cos is -3/5. So we have -3/5 squared minus 4/5 squared. And so now this is 3/5 squared. This would be 9/25. 4/5 squared. 4 squared is 16/25. And so now 9 minus 16, we have -7 over 25. So we have a cosine of this angle, which was -7/25. Moving on, we're going to take a look at the tangent of this angle, or double this angle. So the tangent, and just to point out, we don't know what our theta is, so we can't double it to find it in the calculator because we don't even know what the angle is, so we're using the formulas. So for tan, we don't have any options. Tan of 2 theta is 2 times the tangent of theta over 1 minus tangent squared of theta. So we have 2, and our tangent is 4 over -3, and then 1 minus this -4 over 3 squared. Doing the multiplication, got to remember to look at the screen so you can see, and I'm not writing and you can't see it. 2 times 4, this gives us -8 over 3, and now our 1 minus our -4/3 squared. -4 times -4, we have 16. 3 times 3 is 9. So this here is the answer to our tan of 2 theta. This is where the trigonometry ends. Now from here, we're going to be cleaning this up, and this is algebra. So this is the trig, and up to here is the trig. Now we're going to clean up this fraction. So there's a few ways you could clean this up. I'm going to use the method that involves finding the least common denominator and multiplying numerator and denominator by that. So looking here, if you want, I could put this over 1 so that everything is indeed a fraction. Our denominators are 3, 1, and 9. So our least common denominator would be 9, and that's what I'm going to multiply everything by. So 9 over 1, 9 over 1, and 9 over 1. What that allows us to do is to simplify so we no longer have these little denominators, these little fractions, if you will, in the numerator and denominator. So 3 times divided by 3 is 1, 9 divided by 3 rather is 3. There's nothing to cancel here because our denominator is 1. And here, this 9 and this 9 cancel one another out. So we made a mess, but as usual, sometimes we have to make a mess to get to a more simplified version of our answer. In the numerator now, we are left with 3 times 8, which gives us our 24. And then in the denominator, I should say negative 24. I almost lost my negative sign. In the denominator, we have 9, because 9 times 1 is 9. And then we have 16. So we have 9 minus 16. Continuing this, we have negative 24, 9 minus 16. This is going to give us a negative 7. And so we negative 24 over negative 7, negative divided by negative, this would be a positive 24 over 7. So that would be the process we go through to get sine of double angle, cosine, double angle, and tan of the double angle. I'm going to skip this one for now so the video doesn't get too long. And so if you will, look at the next page of your notes. And we'll take a look at this one, and I think that will be enough for one video, and then I'll come back and do the others in another video. So here, similar to what we did in the section before this, sometimes the information we're given, we don't have to use the formula to find double the angle. Here, what we have looks like one of the formulas, and we're going to use this to kind of, I'm calling it go backwards. So looking at this, this looks like the formula for cosine squared of an angle minus sine squared of an angle. This is equal to the cosine of 2 times an angle. So here, this would be cosine squared minus sine squared. This would be equal to the cosine of 2 times an angle. Well, here, if we identify that our theta is 15 degrees, this is what we're seeing. So therefore, if the theta we're seeing from our formula, this 15 degrees corresponds with that theta, that 2 theta would be 30 degrees. And so now what we're actually looking at is the cosine of 30 degrees, which we know would be square root 3 over 2. So we're not using the formula to find double an angle. What we're given, we're recognizing this is the formula, and we can just find twice the angle given to get our trig function.